In this video, I'm going to solve problems about angular momentum and moment of inertia. Here is problem number one. Number one says that we have a solid cylinder of mass 3.00 kilograms and 50.0 centimeters in diameter rotates about its axis to its center. What is the magnitude of the angular momentum of the cylinder if it spins with an angular velocity of 4.50 radians per second? So we are given the mass of the cylinder. It is 3 kilograms. Then we also have a radius equal to 25.0 centimeters. This is just one half of the given diameter. So we have 50 over 2 is 25 centimeters. So we need to convert centimeters to meters. So we have 25 over 100. So the result is 0.250 meters. And lastly, we also are given the angular velocity, which is 4.50 radians per second. So how do we calculate the angular momentum? So the angular momentum is given a symbol L, and L is equal to I times omega. We are given omega, it is equal to 4.50 radians per second. So to find L, we need to know the moment of inertia. We need to determine first this I. So what is the formula used to calculate I of a solid cylinder that rotates about its axis to its center? Okay, so I is given by the formula 1 half mr squared. So let us put the numbers here. We have 1 half times m, where m is 3 kilograms, times a radius of 0.25 meters, and then squared. So it gives us a moment of inertia of 0.09375 kilogram square meter. Now, since we already have this result of I, we can now solve for L. So L is equal to I times omega. So what we have now is I equals 0.09375 kilograms per meter times omega of 4.50 radians per second. So just multiply them. It gives us 0.422 kilogram meter per second. So the angular momentum of solid cylinder. Okay, so we have the second problem. A solid sphere rotating with an angular speed of 3.60 rad per second about its center of mass has an angular momentum of 1.40 kilogram meter squared per second. The mass of the solid is 8.00 kilograms. Determine the sphere's moment of inertia and its radius. Okay, so again, let us first write what are given. So we are given L, the angular momentum. We have 140 kilogram meter squared per second. Then we have omega of 3.60 rad per second, and the mass is also given. So the mass is 8.00 kilograms. So we are given L and omega. And from the two of them, we can find easily the moment of inertia. Because remember the formula used to find L. L is just I times omega. So solving for I, so it gives us I equals L over omega. So L is 1.4, omega is 3.60. So we have 1.40 kilograms square meter over 3.60 rad per second. Then we have a moment of inertia of 0.389 kilogram meter squared. Okay, so now let us calculate the radius. So to find the radius, we need a formula for the moment of inertia of a solid sphere. Okay, so the formula for the moment of inertia I to a solid sphere is 2 over 5 mr squared. So to find r, we need to derive r squared. So r squared is equal to 5i, just cross multiply this one with 5i, then over 2m. Then get the square root. Okay, so we have now r squared equals 5i over 2m. So we need to get the square root to find r. squared also here. So we have r equals the square root of 5I over 2m. So 5 times I, we have I of 0.389 over 2 times a mass of 8 kilograms. So we have to multiply this one, then over 2 times 8, and then get the square root. Now we have a radius of 0.349 meters, the radius of the solid sphere. Okay, how about the third problem? So we have here the moment of inertia of a rod of length 50.0 centimeters rotating about an axis through one end perpendicular to its length is 0.25 kilograms per meter. So the rod spins with an angular velocity of 2.5 radians per second. So calculate the mass of the rod and the magnitude of the rod's angular momentum. So we have two unknowns here, so the mass of the rod and the angular momentum. So how do you find the mass of the rod? So given L equals 50 centimeters or 0.5 meters, then we have the moment of inertia is 0.25 kilograms per meter and an angular velocity of 2.5 radians per second. So the rod here rotates, okay, around an axis through one end perpendicular to its length. So the formula for that, for the moment of inertia, is I equals 1/3 ml squared or ml squared over 3. We are given m, okay, the mass is, no, not given, but it's unknown. Okay, so the mass here is 3 times I over L squared. So because we have to find the mass, so we have solve for the mass. I have 3I, just simply cross multiply. You have 3I, then over L squared. So m equals 3 times I of 0.25 kilograms per meter over L squared, where L is 0.5 meters and then squared. So multiply and then divide, it gives us a mass of 3.00 kilograms. So after finding the mass, we can now calculate the angular momentum using again the formula L equals I times omega. So we have I equals 0.25 kilograms per meter times omega equals 2.5 radians per second. So we have an angular momentum of 0.625 kilogram meter squared per second.